everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve this problem using the concepts of functions. As per the problem, let f at x equals x minus 2 and g at x equals x squared minus 4. Determine an equation for y equals f at x times g at x, y equals f at x over g at x, and y equals g at x over f at x. Find the domain, range, holes, asymptotes of the combined functions. Let's start with the first part, y equals f at x times g at x. We can use the given function equations. F at x is equal to x minus 2. G at x is x squared minus 4. This is the equation for f at x times g at x. We can simplify this equation by distributing the terms in the parentheses. We can use the FOIL method. Can rearrange the terms. This should be the final answer for the equation of y equals f at x times g at x. This is a polynomial function. It has an odd degree. The degree is equal to 3 and the leading coefficient is positive. So the end behavior for this polynomial function is quadrant 3 to quadrant 1. So the domain for this function is XER. There is no restriction on the domain. In interval notation, the domain can be written as negative infinity to positive infinity. The range for this polynomial function is YER. Because there is no restriction on the range, the graph of this function spans the whole y-axis. We can write this range in interval notation as negative infinity to positive infinity. Since this function is a polynomial function, it has no holes or asymptotes. So we are done with the first part. Now we can analyze the second part. Y equals f at x over g at x. We can sub in the given function equations. F at x is x minus 2. G at x is x squared minus 4. We can simplify this equation by factoring the expression in the denominator. X squared minus 4 can be factored using the difference of squares factoring method. Four can be written as 2 squared. This is the factored form for the denominator. We can cancel out the x minus 2 from the numerator and denominator. This is the equation for y equals f at x over g at x. This is a rational function. This rational function has a hole, a vertical asymptote, and a horizontal asymptote. For hole, we should analyze the factor we cancelled out from the numerator and denominator. We should set x minus 2 equal to 0 and solve for x. I get x equals 2. So the whole exists at x coordinate 2. We should sub in this x value in the simplified rational function equation to find the y coordinate of the whole. I get y equals 1 over 4. That means there is a whole at 2, 1 over 4. We can find the vertical asymptote in this rational function by setting the denominator expression equal to 0 and solving for x. The denominator expression is x plus 2. I get x equals negative 2. So the vertical asymptote in this rational function is x equals negative 2. Now we can find the horizontal asymptote. In this rational function y equals 1 over x plus 2, the degree of the expression in the numerator is 0 because there is no x term in the numerator. The degree of the expression in the denominator is 1 because of the x term. Since the degree of the numerator expression is less than the degree of the denominator expression, the horizontal asymptote in this rational function is at y equals 0. This is a very important concept we need to understand and memorize to solve this type of problem. That if the degree of the numerator expression is less than the degree of the denominator expression, then the horizontal asymptote is at y equals 0. Now we can write the domain and range for this rational function. The domain is affected by the presence of whole and vertical asymptote in a rational function. So we can write the domain as x cannot be equal to the vertical asymptote value negative 2 and the x coordinate of the whole, which is 2. This should be the domain for this function. We can write this domain in interval notation as now we can write the range. For the range, we have to exclude the y coordinate of the whole and the horizontal asymptote value. So that means y cannot be equal to 0 or 1 over 4. We can write this range in interval notation as so we are done with the second part. Now we can analyze the third part. Y equals g at x over f at x. G at x is x squared minus 4. F at x is x minus 2. We can simplify this equation by factoring the expression in the numerator. We can use difference of squares factoring method. The factored form is x plus 2 times x minus 2. We can cancel out the common factors x minus 2 from the numerator and denominator. This is the equation of y equals g at x over f at x. This equation represents a linear function, which is a polynomial function. The function y equals g at x over f at x has a whole because we got a common factor in the numerator and denominator. The whole is at x equals 2. Next, we can sub in x as 2 in the function equation we found to find the y coordinate of the whole. So the whole is at 2, 4. The function y equals g at x over f at x has no asymptotes. Next, we can find the domain. For the domain, we should exclude the x coordinate of the whole, so x cannot be equal to 2. We can write this domain in interval notation as next we can find the range. For range, we should exclude the y coordinate of the whole, which is 4. We can write this range in interval notation as this should be the range for y equals g at x over f at x. So we are done with the third part. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.